We have this problem with a constraint equation of ln x plus ln y equals 4, and we're trying to minimize 1 over x plus 1 over y. And I wanted to share two approaches for this problem, one with AMGM and one with Lagrange multipliers. So with AMGM, what we can try to do is turn this thing into some sort of product and this into some sort of sum in order to minimize this. So using properties of natural logs, we can combine these two into natural log xy equals 4, which if we raise both sides from e, we'll get xy equals e to the power of 4. And we're trying to minimize 1 over x plus 1 over y. So we can try to consolidate these two terms by giving them a common denominator of xy. This will have a numerator of y, and this will have a numerator of x. So this becomes x plus y over xy, which is convenient because we can actually plug in our term xy here. So we have xy equals e to the power of 4, and we're trying to minimize x plus y. So if we use AMGM, x plus y divided by 2 is greater than or equal to square root of xy. And xy is e to the power of 4. The square root of that is e squared. So we have x plus y divided by 2 is greater than or equal to e squared. E to the power of 4, square root of that is e squared. Multiply both sides by 2. And we get that our minimum is 2e squared, which if we plug back in here, we get that the minimum value is 2e squared over e to the power of 4, or 2 over e squared. Okay, that's approach number 1. So now with Lagrange multipliers. So the gradient of this, if you differentiate both of these, we'll get 1 over x and 1 over y and lambda. And the derivative of 1 over x is negative 1 over x squared. With respect to y, it'll be negative 1 over y squared. If we set these equal to each other, and if we solve for lambda, if we multiply both sides by negative x squared, we'll get lambda equals negative x. Here we'll get lambda equals negative y, which reveals something about the values of x and y, and it's that they're equal, which we sort of have to naturally assume using AMGM, but here we make it more explicit. So we get that so if we solve for xy as we did here, we get that xy equals e to the power of 4, and xy are equal, so x and y are equal to e squared. And so we have, if we plug into 1 over x plus 1 over y, we get 1 over e squared plus 1 over e squared, and that's equal to 2 over e squared. So both approaches give us the same answer, 2 over e squared.